Good afternoon to all. Any doubt in last class? No doubt? Okay. If you have any doubt, ask me, no problem. Okay. It's okay. Now we are going to discuss about instantaneous velocity or simply that is called velocity. Instantaneous velocity or velocity. Okay. Already you have studied about the basic concept or definition of velocity in earlier classes like 6th, 7th, 8th standard. Okay. What is meant by velocity? Generally, basic concept, basic definition, rate of change of displacement. Okay. So V is equal to displacement by time. This is basic formula. So it is vector quantity or scalar quantity? Very good. It is vector quantity. What is vector quantity? The quantity which has both magnitude and direction. That type of quantities are called vector quantities. Clear? Okay. Nothing else. Simple. So this is basic formula. So instantaneous velocity or simply that is called velocity. What is the meaning for this? So regarding 11th standard, instantaneous velocity at any instant or at an instant t or simply velocity, it is defined as the limiting value of average velocity. Already you have discussed about, studied about average velocity in last class. I am correct or not? So instantaneous velocity or simply that is called velocity at an instant or any instant t, it is defined as the limiting value of average velocity at as delta t tends to become 0. Okay, this is important. Delta t means time interval. Tends to become 0 evaluated at the time t. Clear? Any doubt? Okay, no, limit. Or simply instantaneous velocity. In other words, simply or velocity. It is defined as rate of change of position vector with respect to time. It is clear? Yes, very good. It is simple concept. This only keep in your mind. Note it this. Okay, so instantaneous velocity or velocity, it is defined as rate of change of position vector. What is position vector? R vector. About this also you have studied in last class. So rate of change of position vector with respect to time. That is called instantaneous velocity or simply velocity. Okay, so V vector, because this is vector quantity. Its unit you can write from this small formula, meter per second. This is the unit of velocity. This is basic formula of velocity. It is vector quantity, so you should be put vector symbol on V. So V vector is equal to limit delta t tends to becomes 0 delta r vector by delta t or dr vector by dt. Because I already told you, simple concept. Instantaneous velocity or velocity, it is defined as limiting value of average velocity as delta t tends to become 0 evaluated at the time t. Okay, or in other words, rate of change of position vector with respect to time. That's all. That's enough. Keep in your mind only this. No need this. So we can written as the simple formula for instantaneous velocity or velocity. V vector is equal to dr vector by dt. That's all. Very important and the simplest formula to find out velocity. Clear? Keep in mind this formula only. Enough. Okay, then in component form. What is component form? Components of a vector already you have studied about this also in last class. So in component form, V vector is equal to dr vector, basic formula, dr vector by dt. Here r vector, already told you just now. Very good. Position vector. Position vector. It is equal to x I cap plus y j cap plus z k cap. That means there are mainly three axes, no? X axis, y axis, z axis. Okay, x, y and z axis like this. So x axis, y axis and then z axis. This is position vector. Okay, what is meant by I, j and k cap? Unit vectors. Very good. Its value, that means its magnitude always 1. Okay, so this is the formula for position vector. 3 axes, x, y and z. 3 axes. So v vector is equal to d by dt of r vector. So v vector is equal to d by dt. What is r value? X I cap. At the same time here I, j, k caps unit vectors along x axis, y axis and z axis. I cap along x axis, j cap along y axis, k cap along z axis. Very simple this. Already you have studied about this. So plus y j cap plus z k cap. That's all. Okay, now v vector is equal to dx by dt multiply into I cap dy by dt j cap dz by dt k cap. This is another formula for velocity. See this? Okay, here dx by dt is equal to vx. Dx by dt is equal to v suffix x. It means x component of velocity along x axis. Okay, it is equal to x component of velocity. Then dy by dt is equal to v suffix y. It is equal to, very good. Come on, tell me yourself. Very good. Y component of velocity. Y component of velocity. along y-axis. Okay. Then similarly, dz by dt is equal to v suffix z. That means vz. It is equal to yourself like this. Very good. Z component of velocity. Okay. It is equal to x component of velocity along x direction. That means x-axis. It is equal to y component of velocity along y-axis. It is equal to z component of velocity. That means along z-axis. Along x-axis, along y-axis, along z-axis. X, Y, Z like this. Okay. Okay. Then next very important formula for speed. This is velocity, but now we are going to discuss about speed. Okay. What is speed? What is velocity basically? Displacement by time. Clear or not? Yes. What is meant by speed? Very good. You are correct. Distance by time. That's all. Velocity is equal to displacement by time. Speed is equal to distance by time. What is the difference between them? Yeah, very good. It is vector quantity. Yes, this is scalar quantity. Displacement, vector quantity. Distance, scalar. I am correct or not? Like this. But unit, both are same unit. For displacement, meter. For time, second. So, meter per second. For distance, yeah, meter. So, the unit for speed also meter per second. But basic formula, distance by time. But here, speed it is defined as the magnitude of velocity. Speed it is defined as the magnitude of velocity. Okay, it is a scalar quantity. Always its value positive. Keep in your mind. Always positive. Because distance always positive, no? But displacement may be positive or negative. Okay, so always positive. This scalar quantity. Unit meter per second. Okay, come and tell me yourself what is speed? Distance by time. Okay, this is basic formula. But regarding 11th standard in second unit kinematics, come and tell me yourself. Very good. Magnitude of velocity. Very good. That is called speed. So, speed v vector is equal to. I am correct? This is correct? No. This is wrong. Because speed. Very good. You are correct. Only v. Because it is a scalar quantity. You are correct. V is equal to magnitude of velocity. Okay. That is called speed. Okay. What is the formula? Come on, right? Because already discussed about this formula in components of a vector and also scalar product of two vectors. Come on. Yourself. Very good. V is equal to root of vx square plus v suffix y square plus v suffix z square. Yes, very good. This is the formula for find out speed. Okay, what is speed? Very good. Magnitude of velocity. V is equal to root of vx square plus vy square plus vz square. Here you must take, while find out speed, compulsory you must take only magnitude of velocity. Clear? Clear? Okay, come on. Just see. Go through this. Go through this. Okay, clear? Any doubt? Any doubt? Come and ask, no problem. Clear? Okay, shall we move to next? Discussing about some problems relevant to instantaneous velocity or velocity. Okay. Now we are going to discuss about example problem 2.21. I think page number, take your book, textbook, come on. Quick. Take all of you. 2.21, page number 67. Okay, yes. First, what are the steps for solving the problems? First, you must read word by word thoroughly and extract the data and write in symbol, and you must find out formula and you go to solution. Okay, so first, given data, come on, the position vector of a particle is given. This is the position vector. Okay, r vector is equal to 2t I cap plus 3t square j cap minus 5k cap. Okay, first we should be find out the velocity and speed of the particle at any instant t. What is the time? We don't know. The time is equal to here t. That's all. Any instant t. And again we should be find out here time is equal to t and b. Ditto. That means calculate velocity and speed of the particle at a time t is equal to 2 seconds. Okay, that's all. So velocity and question mark for t is equal to 2 seconds. Okay. So next, you should be right formula. No. Okay, what is the formula? Er vector by dt and v is equal, sorry, this is for velocity, it is for speed. Vx square, v square plus v z square. Okay, that is the formula. Okay, but is here now solution. First, a time here t, no. First we should be find out velocity at any instant t. So v vector is equal to dr vector by dt. So d by dt r vector, you should be substitute r value in this formula. What is r value? Here, written here, no, or here. 2t I cap plus 3t square j cap minus 5k cap. Okay, d by dt means differentiation, no? Differentiate. Already you have studied about this. Okay, in mathematics. Now, how do you differentiate this? Power 1 2 are 2. Here will be power minus 1, no? So therefore 2 t power 0 plus 2 3s are 6. Remain here this is 1 in power, no? So 6 t1 minus 5k. What is the meaning of this? Position vector here, it has minus 5 along z-axis. Okay, so it is constant value along negative z-axis because of minus 5. Along negative z-axis because of minus 5. So it is constant, no? Because there is no t. T means, yeah, time, independent of time. So position vector, it is constant. Okay, so there is no velocity component. I am correct or not? In or along z-axis. So taking differentiate for this constant 0. So leave it. So j cap. Therefore, v vector is equal to 2 t power 0 is equal to 2 I cap plus 6t j cap. This is velocity at any instant. Okay, then speed v is equal to root of vx square plus vy square. Okay, leave it this. Already calculated velocity value, clear, at a time t. See here. Now we should be calculate speed. What is speed? Magnitude of velocity, clear? Because velocity here only along only two axes, no? Along x axis and along y axis. So here we must take only magnitude. Okay? So root of 2 square, leave it this. Here take only magnitude. And also v suffix y square, no? So 60 whole square. This is speed. Very good. Meter per second. Meter per second. Okay. At instant t, not time 1 second, 2 second like this. At time at any instant t. That's all. Okay. Second one. That means a b. Listen. Come on. Calculate the velocity and the speed of the particle at any instant t. Okay, calculated. Then at time t is equal to 2 seconds. That's all. What to do? Yes, very good. We must substitute 2 seconds for time. That's all. Okay, listen here. First velocity at a time t is equal to 2 seconds. V vector is equal to 2 I cap plus 6 into 2 j cap. Therefore 2 I cap plus 12 j cap meter per second. This is velocity of the particle at time t is equal to 2 seconds. 2 I cap plus 12 j cap. Okay? Then, come on. At the same time, speed of the particle at a time t is equal to 2 seconds. What to do? What is the formula here? We already calculated. Okay, so for speed, v is equal to root of 2 square 60 whole square, no? So here 2 square 4, 6 into 2 whole square, root of 4, 6 2s are 12 square. So root of 4 plus 144, it is equal to 148. It is equal to 12 point something. So 12.16 meter per second. 12.16. So that is the value of speed at time t is equal to 2 seconds. Okay? Okay. Wait. Now take your book. Page number 67. Come on. See the last line. Already told you. But last line underline. Note the particle has velocity components along xy direction. Full stop. Along z direction, the position has constant value. Already told you. Okay? Underline this. While asking this problem, you must write 1, 2, 3, 4, these 5 lines also. Okay? Otherwise, no marks. Okay? So, along z direction, the position has constant value of minus 5, which independent of time, no time. So hence there is no z component of velocity. Underline quick. Okay, close the book. Next we are going to discuss about example problem 2.22. Okay. Take a book, page number 67. See example problem 2.22. Come on, read. The velocity of the three particles A, B, C. Three particles given. Which particle travels at the greatest speed? Okay. VA 3 I cap minus 5 J cap plus 2 K cap. Okay. Velocity of particle B I cap plus 2 J cap plus 3 K cap. And the velocity of the particle C. Okay. Which particle has or travels greatest speed? Okay. What to do here? We must find out. Yeah. Magnitude of velocity. Okay. That is called speed. Okay. One by one. Now, more time. So, directly going to discuss solution. Okay. First. Velocity of particle A. Come on, tell me. Formula, general formula, okay, already written. But if you take only magnitude, no. So therefore, 3 square plus minus 5 whole square plus 2 square. Okay. So root of 9, 25, 4. So 9, 13, 25. So root of 38 meter per second. Okay. Then come on, find out. Next, the speed of particle B. VB. We can write directly 1 square plus 2 square plus 3 square. So 1, 4 plus 9, 14. Okay. Root of 14. Clear? Okay. Meter per second. VB. And VC, square root of 5 square, only taking here magnitude. 5 square, 25. 3 square, 9. And 4 square, 16. So, 25, 9 and 16. Okay? $14, 20, okay, 50 meter per second. Okay, so here comes 6 point something. Okay, real value. Here 3 point something. Okay, here comes 7.0, 7 point something. So which particle has greatest speed? Come on, tell me. 6 point something meter per second, 3 point something meter per second, 7 point something meter per second. So the particle C has greatest speed. Okay. So take a book, page number 67. Come on. Write nearest to this value, 6.16 meter per second. Come on. And here 3.7 meter per second, not given in your textbook. Okay, till this enough, no problem, but you write no problem. And for root of 50, 7.07 meter per second. Come on, quick. So underline the particle C as greatest speed. Okay, then last problem. Come on, this is no calculation, only concept oriented problem. This example 2.23, page number 67. Come on, read. 2.23. Two cars are traveling with the respective velocities. v1 vector 10 meter per second along east, and v2 10 meter per second along west. What are the speeds of the cars? Come on, tell me. Don't see your book. Solution. Hide the solution. Only see the question. Come on. Yourself. Very good. Both cars has same speed. Very good. Why? Because here magnitude same. Because of speed it is defined as magnitude of velocity. No. So here given same magnitude 10 meter per second is 10 meter per second. But the direction different. No need here direction. Because of speed it has only magnitude of velocity. Clear? So both cars are same speed. But the direction will be same. But direction will be different. Speed same. Because of magnitude same. Clear? That's all. Okay, next. Momentum. Okay, now momentum. Already you have studied about this in 10th standard also. Okay, very simple concept, nothing else. Momentum, basic formula, linear momentum or momentum, but angular momentum that is different. Momentum or linear momentum, okay, but angular momentum that is different. So linear momentum, P vector is equal to m into v vector. That's all. Okay, come on, define this. Momentum or linear momentum of a particle, it is defined as product of mass and velocity. That's all. So its magnitude we can written as P is equal to mv. It has vector quantity. So vector means it has both magnitude and direction also. So what is the direction of momentum? In the direction of velocity. That's all. Because this is scalar quantity mass. Okay. So this is magnitude. What is the unit for this? We can written as kg meter per second. It is unit for momentum. At the same time, in component form. Come on. Px I Py j cap plus Pz j cap. It is equal to m Vx I cap plus m Vy j cap plus m V suffix z k cap. That's all. Here Px is equal to m Vx is equal to momentum of along x component or momentum of x component simply, and Py m Vy is equal to y component of momentum. This is x component of momentum. This is equal to y component of momentum. Similarly, Pz is equal to m Vz. It is equal to z component of momentum. It is equal to x component of momentum. It is equal to y component of momentum. It is equal to z component of momentum. Px is equal to mvx. Py is equal to mvy. Pz is equal to mvz. That's all. Velocity along x-axis, velocity along y-axis, velocity along z-axis. Okay. But combined mvx, momentum along with x-axis, momentum along y-axis, momentum along z-axis. That's all. Okay, small example. What is the role of momentum in our life or in physics? It is a very important one thing. Momentum in our life. Okay, we can understood from small example. Consider here one mosquito and one train or car. Mosquito, car, okay? Both are moving towards you, hit on your body. Now, what to do? Yeah, after hitting mosquito and car on our body, we can feel different pain in our body. Am I correct or not? Yeah. At the same time, here which is greatest momentum? Car or mosquito? Even both are traveling or moving towards you with the same velocity. That is important. Keep in your mind. Same velocity. Be same. Be same. So here momentum depends upon only V or only mass. No, it depends upon both mass and velocity. But here velocity same. For example, 10 meter per second or 5 meter per second. Velocity of mosquito and velocity of car also 5 meter per second. Both are traveling same speed. Okay. So here greatest momentum for car or mosquito? Car. Very good. So car only creates damage on your body. Because of that's very greatest mass. Okay. Very good. So even both particle traveling with same velocity. Okay, but momentum depends upon mainly mass. Then speed is same. Okay, so car has greatest momentum. So this car creates damage in your body. Am I correct or not? So the momentum which plays major role in explaining state of motion of the object in physics. Okay? Any doubt? Okay, next, only one problem. Come on, take your book. Simple problem. Page number 68, 2.24. Simple problem this. 2.24. Consider two masses. M1 is equal to 10 gram. M2 is equal to 1 kilogram. But the speed same, okay? Consider two particles of masses 10 gram and 1 kilogram moving with the same speed. 10 meter per second. Calculate magnitude of the momentum. Calculate magnitude of the momentum. Okay, so how do you calculate this? With the help of formula? No? Listen. Here, first P1. At the same time, we must convert it into kilogram. No? So 10 into 10 power minus 3 kilogram because given in gram. Here directly given in kilogram, no need to conversion. So P1, M1V because of V same. So M1 10 into 10 power minus 3 into 10. So 100 into 10 power minus 3 or 1, 2, 3. So 0.1 kilogram meter per second. This is P1. This is P1. Okay. P2 is equal to M2 into V because V same. It is M2 1 into 10. So 10 kilogram meter per second. It is equal to V. So speed same, okay, but mass different. Okay, so mainly here even when speed is equal to same, momentum of a particle depends upon mainly mass. So P1 0.1 kilogram meter per second, P2 10 kilogram meter per second. So how many times greater Very good. 100 times greater. I'm correct or not? So, take a book. Page number 68. Underline, come on. Thus, even though both masses have same speed, underline quick. Same speed, the momentum of the heavier mass for 1 kg, heavier mass is, underline, 100 times greater than that of lighter mass. Underline this 1, 2, 3, 4 lines. Quick. Okay. Thank you.